So approximate intercepts. Approximate intercepts are no different than regular intercepts, except that we're taking a rough approximation. That's about it. So in this case, we have y equals negative 2.67x plus 8.97, and we're going to substitute y equals 0. So we're going to have equation like 0 equals negative 2.67x plus 8.95 and solve for x to obtain the x-intercept. Substitute x equals 0 into the equation, and we're going to have it in the form of y equals negative 2.67 times 0 plus 8.95 and solve for x to obtain the x-intercept. Well, let's try it out. Do notice this is in the form of y equals mx plus b, which makes it a little bit easier in the long run. So let's try it out. Y equals negative 2.67x plus 8.95 is the equation that we're using for this case. So y-intercept, we know it's in the form of 0 comma something, and x is the value that is 0 for our y-intercept. X-intercept, we know that it's in the form of something comma 0, and we know that y is the one that is 0 for our x-intercept. Something to remember. Y-intercept, you know x is 0. For the x-intercept, you know that y is 0. I suggest you memorize this, okay? So, our equation, y equals negative 2.67x plus 8.95. Let's substitute the value of 0 in for the x. Negative 2.67 times 0, well, that just leaves us 0. 0 plus 8.95, right? And 0 plus 8.95 is just 8.95. So there is our y-intercept value, 8.95. Let's plug into our coordinate here. And we might as well graph it. Do be aware, we may have done quite a bit more work than we wanted to. Do notice that our equation, y equals negative 2.67x plus 8.95, already contained the 8.95. So in many cases, if it's in the slope-intercept format, all you need to do is just visually see what the v-value is. The v-value is 8.95, agreed? So now let's plot our y-intercept. So let's label x and y-axis, there it is. And we're going to roughly approximate 8.95 on our graph. Once again, this is a rough approximation. It's probably close enough to 9 that we can call it a 9, agreed? So there it is, roughly 0, 8.95 location, or roughly 9 would be the closest value. It almost looks like it's at 9, agreed? So y-intercept is graphed now. We see a red dot on our graph. Now let's calculate the x-intercept. So that implies that an equation, y equals negative 2.67x plus 8.95. That's our original statement, right? We are substituting 0 for the y. So that means we're solving for x in this case. So we gotta get rid of the 8.95, which is adding. Always get rid of addition first. So minus 8.95 from both sides. On the right side, it cancels out 8.95 minus 8.95. On the left side, 0 minus 8.95, well, that just gives us negative 8.95. Negative 8.95 equals negative 2.67x. And notice, negative 2.67 is multiplying with the x, because there's nothing between the number and the x. So opposite of multiplication, division. Let's get rid of by dividing. Negative 2.67 from both sides. On the right side, negative 2.67 cancels out with negative 2.67. That leaves us with just the x. On the left side, negative divided by a negative makes us a positive number. 8.95 divided by 2.67, this is where your calculator comes in really handy, agreed? Or practicing those long divisions. So either would work. In this case, dividing it out, notice our 2.67 cancels out on the right, and dividing negative 8.95 by negative 2.67 gives us 3.35 is our x value. So that means this is our x value of the intercept. So let's plot into our intercept coordinate. There it is. So our x-intercept is at 3.35 roughly, 0. So let's plot our location or our coordinate point. There it is. And once again, this is just a rough approximation. From my point of view or your point of view, it could look like it's at 3.5 maybe, roughly. But it's close enough as a reference. Do be aware, you're just doing rough approximations when you're plotting, okay? So, connect the dots. That way we have our graph now finally completed. So, this is our completed graph of our equation y equals negative 2.67x plus 8.95 using the intercepts, and this is based on approximate values.